Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to another chemistry class. I am Saliu Abdul Wahab, your chemistry teacher. And in this class, we want to look at the limitation of Dalton's atomic theory. In our previous class, we discussed the Dalton's atomic theory, and from his experiment, he came up with some assumption that atom is made up of indivisible particles, very tiny, and these tiny particles are known as atoms. Atoms of the same elements are exactly alike and differ from atoms of other elements. Now, when atoms combine, they do so in whole number ratio. All chemical combinations are based on the combination of atoms. Then we said that this theory has some shortcomings. We want to quickly look at the shortcomings and their modification. Now let us look at the first theory that Dalton's gave us. Dalton's atomic theory has some limitations because there are modifications of some of his theories, like as we have said. Based on new scientific evidences, the idea that matter is made up of tiny particles remain the same. The idea that matter or atom is made up of tiny particles remain the same. Now let us look at his limitations, where the shortcomings arise, and let us see how we can modify it. From Dalton's atomic theory, he says that atoms of the same element are exactly alike and differ from atoms of other elements. But from the discovery of the mass spectrometer, we are able to see that atoms of the same element may not be alike, may not be exactly alike, especially in the case of the existence of isotopy. And isotopy is defined as a phenomenon where atoms of the same element exist in the same atomic number but with different mass number. An example is given as chlorine. Chlorine exists in two isotopic forms. Chlorine with atomic number 17 and mass number 35. And another isotope is that of chlorine with atomic number 17, mass number 37. However, when you compare these chlorine atoms, you will discover that they are atoms of the same element when you compare both. And you will also discover that they have the same number of protons and the same number of electrons, which represent their atomic number. But comparing the atomic masses, you will discover that the first has an atomic mass of 35 and the second has an atomic mass of 37. This is a difference that arises because of the difference in their number of neutrons. Now, when you look at these two atoms of chlorine, they are having the same atomic number but different atomic masses. And of course, to find their number of neutrons now, it is going to be atomic mass minus the atomic number. And that gives us 35 minus 17, which is equal to 18. Of course, the first chlorine isotope, which is chlorine 35, has 18 neutrons. While the second isotope of chlorine, known as chlorine 37, has a mass of 37, atomic number of 17. Number of neutrons now will be equal to 37 minus 17, which gives us 20. And the number of neutrons is 20. Therefore, the number of neutrons in the two isotopes now are 18 and 20 respectively. 18 and 20 respectively. Now, from that, we should know that atoms of the same element are not exactly alike, based on that theory that atoms of the same element are exactly alike and differ from atoms of other element. Atoms of the same element may be different in as much as far as there is existence of isotopy. Now, when you look at the second, atom is now known to contain subatomic particles. According to John Dalton, he said that atom is the smallest indivisible particle of an element. Take for instance, a woman that is pregnant with probably twins or triplets will have fetus that are smaller than the mother. Therefore, when we define the mother, we will not define the mother as the smallest existence, but the triplets or the twins will now be the smallest. Therefore, atom is known to consist of protons, neutrons, and electrons. Therefore, an atom is no longer the smallest indivisible particle of an element, but then an atom is an indivisible particle of an element, not the smallest indivisible particle of an element. Now let us quickly look at this exercise. And the exercise is asking us to state the limitations to any two of the Dalton's atomic theory. Remember, we have given 4. Having given 4, pick any of the two and state the limitation to those theory. Pick any two and give us the limitation. Should in case you have problem with it, subscribe to our channel and then you will have the limitations to all of them. In our next class, we shall be looking at the composition of an atom. Thank you very much. I remain Saliu Abdul Wahab, your chemistry teacher. Do subscribe to our channel. Thank you.